Howdy howdy, this is Mr. Potter, and we're going to start a series of logic videos to explain the basic underpinnings of logic. So the first thing we're going to be doing today is we're going to be talking about some basic information. We're going to be talking about some definitions, we're going to be talking about statements, what a statement is, and different types of statements such as negations and conjunctions, and also how we're going to use statements in truth tables. So we're going to start by talking about what a definition is and what a definition is not. A definition has two key points. A definition has to have an is a part and a has a part. A definition has to have those two parts. The is a part tells us what type of category that we're looking at, and the has a part is the distinguishing feature. In other words, what makes it different from every other element in that category. And we'll get to what a definition is not in just a moment, but I want to talk about a car. A car is what? A car is a vehicle, because what it does is it transports things, people, objects, something. It is a vehicle, but how do I distinguish it from other vehicles, say a truck or a bicycle or a train or an airplane or a submarine? So now I need to start talking about different qualities that a car has that these other vehicles don't. So I can talk about is a vehicle that does what? Well, I know generally it has four wheels. An engine, because I'm not going to say like it's a bicycle or a wagon. Has four wheels, has an engine, usually has 2 or 4 doors, and it carries people. I mean, that is kind of the chief purpose of a car, is that it's going to carry people around. So these are aspects of a good definition for a car. So if I wanted to talk about a good definition for a car, I would say something like, a car is a vehicle that has an engine, 4 wheels, 2 or 4 doors, and carries people. And so what I've done here is I've given you the is a part. I've told you what a car is. It is a vehicle. And I've told you the has a part. What does a car have? Either an object that the car has, or a property that a car has, or a principle that a car has that other vehicles don't. So it has the engine, it has 4 wheels, it has 2 or 4 doors, and it carries people. And of course I can make this definition more specific if I need to. I can make this definition more general if I don't feel like writing a lot of stuff. But I need these 2 parts. I have to have the is a part, and I have to have the has a part. And if I don't have those parts, then I don't have a good definition. So I said I'd go back to this and I'd say, what is a good definition not? Well, a good definition is not a place, because I'm not going to say a car is where. Okay, that's bad. And it's not a time. I don't want to say a car is when. Okay? Those are 2 things that I don't want to use. I don't want to use these words where or when I'm giving a definition. It's not going to be a good definition. I want to use the word is, and I want to use these distinguishing characteristics. Now, I don't have to use this word has. I can use other words instead that have that same meaning. So this is what's really important. In our class, and in mathematics in general, a very precise definition, a very clear definition is essential. So that's the first thing that we need to talk about, is what makes a good definition. So what I'm going to be doing in this class is I'm going to be giving you terms, And in order for us to use these terms, I have to give you a very precise definition of what I mean by these terms. And so the first term that we have, the first real key word that we have, is a statement. So I need to tell y'all what a statement is. Okay? So here's our definition of a statement. A statement is a sentence that is either true or false. A statement is a sentence that is either true or false. Notice that I've got this is a part, this category, and it belongs to this category of sentences. And we'll talk in just a few minutes about what I mean by a statement as opposed to other types of sentences. But I'm also giving you how it's distinguished from those other sentences. I'm not using the word has, but I am using a form of that verb. It's either true or false. So the next question then, of course, is what is not a statement? So if I'm talking about things that are not a statement, I don't want to use questions. Okay? These are what we call interrogative sentences. And so these are sentences like, how much is that doggy in the window? Or, can you tell me how to get to San Jose? These are not statements. These are not true or false sentences. These are questions. These are trying to gain information as opposed to giving you information. I don't want exclamations. Exclamations. I don't want to use things that would require an exclamation point or a comma if the feeling's not as strong. So I don't want to say, ow, my hand! Because that's not a true or false sentence. That's really just an exclamation. I'm kind of saying something for the purpose of showing emotion, expressing anger, outrage, pain, what have you. So a statement is not a question, a statement is not an exclamation, and a statement is not a command. Hand me a pencil. Okay? That is not a statement. I can't say hand me a pencil true or hand me a pencil false. Now, if you do hand me a pencil, he handed me a pencil would be a true statement. She didn't hand me a pencil would be a false statement. So these are examples of sentences that are not statements. So here's the main idea. This is one of the two big principles that we use in logic. In logic, we deal with statements and we try to determine when they are true or false. That's really one of the main ideas in logic, and we have tools to help us determine when statements are true and false. There are patterns that we recognize to find out when a statement is true or when a statement is false. And as we're using statements, I want to use a lowercase letter. That really is the symbol for a statement. So if I have a statement like, the tree is tall, I may want to use a lowercase t to represent that, because that t represents the treeness of the statement, or the t represents the tallness of the statement. And this is a sentence where, in the context of this sentence, it should be clear whether or not it's true or false. At this point, you have no idea what tree I'm talking about, so in this context, it's not a good statement. But if I am in a park and there is a 100-foot tall tree, and I say, oh, the tree is tall, you know exactly what I'm talking about. You can ascertain the truth value of this statement. You'd say, yeah, that's a true statement. Or if I'm standing beside a 3-foot tall shrub and I say, oh, look, the tree is tall, you're like, no, I don't think so, Mr. Potter. That looks false to me. So we have this concept of a statement. A statement is a sentence that's either true or false. And I'm going to be saying these definitions almost like a mantra. I'm going to be repeating these word for word. We have to know these verbatim because these are good definitions. The next thing that we're going to be talking about are negations. And again, I'm giving you a sentence, I'm giving you a term, so you expect a good definition. And a good definition has to have the is a part and a has a part. Now, I mentioned before that in logic we deal with statements. So a negation is a statement. But now I need to distinguish it from all of the other statements that are out there. A negation is a statement that has the opposite truth value of a given statement. Okay? A negation is a statement that has the opposite truth value of a given statement. In other words, if I have something like the tree is tall, and that's true, then the negation of that statement should always be false, because those are opposite truth values. A true's opposite is false. And similarly, if I have a sentence that starts off false, the opposite of that is true. So a negation is a statement that has the opposite truth value of a given statement. So the question then comes, how do we take the negation of words where there is no clear opposite? Because I've got cold. And if I ask you what the negation of cold is, a lot of people would like to tell me that the opposite of cold is hot. And if I ask people what the opposite of tall is, people would like to say the opposite of tall is short. But we run into some problems where if I'm talking about a word that doesn't have a clear opposite to it. So what is the opposite of yellow? Do I look at a color wheel and say, well, if I look at the color wheel, the opposite of yellow would be purple? That doesn't make sense, because if I was to tell you this sentence is yellow, clearly that's a false statement. And if I change it to this sentence is purple, that's true as well. But if I do the exact same way this way, this sentence is yellow, that's false. But if I write this sentence is purple, that's false as well. So this doesn't have the opposite truth value. Remember, that's what we need for a negation. A negation is a sentence that has the opposite truth value of a given sentence. So what we need to do is we need to talk about this from the context of, how do I make something the opposite? So what is the opposite of cold? Is the opposite of cold hot, or tepid, or on fire? Or could I do something a lot simpler and just say not cold? Because if I just take that sentence, this room is cold, and let's say that's a false statement, as soon as I stick the word not in there, that gives it the opposite truth value. So the opposite of a word really needs to involve the word not. What's the opposite of tall? Well, it's not tall. What's the opposite of yellow? Well, it's not yellow. The opposite of me having a yellow shirt would be me having any other shirt that's not yellow. So the key idea behind a negation is that we're going to be put a not in or take it out. Whenever I'm dealing with the negation of a statement, I'm either going to be putting a not into the statement, or I'm going to be taking the not out of the statement. So let's say I've got this sentence. This sentence is blue. The opposite of this would be, this sentence is not blue. And again, notice I'm using a lowercase letter to represent this sentence as blue. In order to represent symbolically the opposite of a sentence, I'm going to put a tilde in front of that letter that we're using. B represents the sentence, this sentence is blue. So negation B, tilde B, is going to represent the opposite of that. The sentence is not blue. And of course, here I've got this even more complex sentence. The background is purple with polka dots. Well, clearly it's not. Clearly it's black with a grid on it. So if I want to talk about negation P, the opposite of P is the background is not purple with polka dots. So the whole idea behind taking a negation of a sentence is to either put the word not in or to take the word not out. Now, this as an aside, in a lot of advanced logic books, you'll actually see this symbol as the symbol for a negation. But most typewriters don't have this symbol, and so as a matter of convenience, you'll start seeing this symbol as well, this tilde. And of course, you may be familiar with this from Spanish by seeing that as what's above the ñ in Spanish. But this is the sentence that we're really going to be, that's the symbol that we're really going to be using for negation. So, the next thing I wanted to talk about is, in logic, we're really, really, really concerned with when a statement is true and when a statement is false. So, I mentioned that we have a tool to determine when a sentence is true or when a statement is false, and that's a truth table. A truth table is a table that shows all possible truth outcomes. Okay? A truth table is a table that, what makes it different from other tables? It shows all possible truth outcomes. So I've got this P statement, and P could be the statement from before, the background is purple with polka dots. And you know what? Maybe in tomorrow's lesson that'll be true. But it's not true now. And remember that a statement is a sentence that is either true or false. When I'm doing the negation of a statement is a statement that has the opposite truth value. So what is the opposite of true? It's false. And what is the opposite of false? It's true. So this truth table is a table, and it's showing all the possible truth outcomes. P is either true or false. And if P is true, then negation P has to have the opposite truth value, so it must be false. If P is false, then negation P must have the opposite truth value, so it has to be true. So we're going to be talking about truth tables extensively in this course. We'll be talking about using truth tables to determine when a statement is true or when a statement is false. So our last statement for today's lesson is a conjunction. The whole idea behind a conjunction is a conjunction puts things together. And in English, the main conjunction that we use is a word like and, where we'll put two sentences together and make it a compound sentence. So that's what we're going to be doing here. We're going to be putting two statements together to get a compound statement. So a conjunction is a statement that is only true if both given statements are true. A conjunction is a statement that is only true if both given statements are true. So let's say I've got P as a statement, the room is dark. Q is the statement, Mr. Potter's tie is blue. And I want a sentence that's only true if both of these statements are true. And remember, this is a conjunction. This is the symbol for a conjunction, by the way, this inverted V, this hat character, the caret. This is Shift 6 on your keyboard, by the way. So I want a statement that's only true if both of these statements are true. The room is dark, Mr. Potter's tie is blue. So if I wanted to write this sentence, I would say, the room is dark and Mr. Potter's tie is blue. The symbol is this caret, and the key word that we're going to be using for a conjunction is and. So whenever I want to do a conjunction, I'm going to put two statements together with the word and in between. Now, if the first part's true, the second part's true, and makes them both true. Or is actually something we'll talk about in another lesson. So, the last thing I want to talk about in today's lesson is I want to talk about the truth table for conjunctions. So, this is a little bit different than the truth table that we had before because we have two different statements, P and Q. And to be quite honest, whether or not I wear a blue tie has nothing to do with the room being dark. But I do know that a statement is a sentence that is either true or false. So either the room is dark or it's not dark. But if the room is dark, maybe I am wearing a blue tie, maybe I'm not wearing a blue tie. So I have to have these two situations that both exist when the room is dark. And similarly, maybe I am wearing a tie, maybe I'm not wearing a blue tie if the room is not dark. And this is a power of two property that we'll be talking more about in tomorrow's lesson. The idea here is that if I want to show all possible truth outcomes, well, P is a statement that's true or false. So that's two outcomes. Q is a statement that is either true or false. That's two outcomes. And 2 times 2 is 4. Now, remember the definition for a conjunction. A conjunction is a statement that is only true if both given statements are true. In this first row, are both given statements true? Yeah. And does it happen in any other row that both given statements are true? And the answer is no, it's not. And so this is really the key here. The only time that a conjunction is true is when both of these given statements are true. Whenever I see TT in my truth table, that's when I know that I'm dealing with a true conjunction. So, today what we've talked about are 4 main ideas. We talked about the concept of a statement. We talked about a negation. Remember, a negation is a statement that has the opposite truth value of a given statement. We talked about what a truth table was. A truth table is a table that shows all possible truth outcomes. And then we talked about conjunctions. And a conjunction is a statement that is only true if both given statements are true. So, you need to know these terms in order to be successful in logic. And you'll need to know these terms for tomorrow's class. So, thank you very much for watching my video. This is Mr. Potter, and I'll see you in class.